Okay, the first thing I'd like you to explore is the relationship between an equation and the graph of the equation. So let's see what's meant by the graph of an equation. Now let's start with a simple object, and we're just choosing it because it's fairly simple. It's a straight line. Okay, so the straight line is here determined by points A and B. Notice I just put the 2 points down. Then if I hit the select type arrow over here, I can move these around. And as I do, notice over here is the equation. This is dependent objects. Here's point A, point B, and this object was created, which is an equation. And it says minus 1.68x plus 4.6y equals 15.08. Okay, that's the equation. And as I change the line, that equation changes. Okay. So the question is, what is this equation all about, and what's the connection between the equation and the line? What the equation is the following. If you take any point, let's just take a point here, and let's put it anywhere on the plane for a minute. Okay, so this is point C. And point C is given here by 1.82, 2.92. All right. Now I'm going to split those apart, so these are called the x and the y coordinates of this point. The way I can split them up is this. I'm going to create a number called cx, which will be the x component of c, and say that cx is equal to the x parenthesis capital C. It'll be the x component. That should come out equaling 1.82. Let's see. There it is. All right. So this cx is the first number of this pair. Similarly, if I make another number called cy equals, I'm going to say this is the y component of c. I put a y parenthesis, a capital C for the point, and it comes out 2.92, which is the y component, the second component of this point. All right. Notice the c at the moment is not on the line. It's just some point out here somewhere on the plane. So what I'm going to do is take this pair of numbers that represent point C, that's the 2.14 and the 2.34. I'm going to plug them into this equation. And so I'm going to say, let's give the name to the result. I'll just call it result. Equals. Now I'm going to take this equation and use this as my guide. So I'll take minus 2.48. I'll say minus 2.48 times Cx. All right, and that'll give me this number, and it'll plug it in where the x is. And I'll say plus, and then take 4.34 cy, which is the y number here. So instead of using just x and y, I'm taking this particular x, which is cx, and this particular y, which is cy, and I'm plugging those into this equation, and the result comes out 4.85. Not 12.47. Okay? Now watch what happens as I move point C around the plane. Look at all the numbers that are changing here. Point C, the coordinates here are changing. The separate coordinates are changing, and the result is changing. Okay? And so if I'm way off here, as I get closer and closer to the line, notice that when I'm approximately on the line, the result is approximately 12.47. Okay, let's go over here on the line. I'm going to get pretty close to the line, 12.49, 12.44. But they're not exactly on the line. But anytime I'm close to the line, the result is close to this number. Okay, and if I'm far from the line, the result's totally different. Okay, so in other words, this equation tells a relationship between the x and the y for points that are on the line. Okay, so watch this. I'm going to go to Tools and Point Tools, and it says Attach Detach Point. Okay, so it says to attach or detach a point, click on the point and then the object you want to attach it to. So I'm going to click on the C and then the line. Now, notice when I put the C on the line, let's go back to our selection tool and move tool. If I slide C along the line, notice what's happening to the result. that result stays 12.47 regardless. Okay, so the equation gives us a relationship between the x and the y of every point on the line. Okay, so any point, any xy pair that satisfies this equation will be some point on the line, and any point on the line, the x and y from that point will satisfy the equation. Okay, so algebraically we're saying this equation is true. There's a relationship between the x and the y of a point, and if it satisfies that relation, it's on the line. Okay, and as long as it's on the line, it'll satisfy the relation.